The question says 6.3 grams of NaHCO3 are added to 15 grams of CH3COH. The residue is found to weigh this much. What is the mass of CO2 released in the reaction? For this, it is good that you know what the reaction is when sodium bicarbonate, this is sodium bicarbonate or sodium hydrogen carbonate, reacts with acetic acid. When it reacts with acetic acid, it produces sodium ethanoate, water, and CO2. So the only gaseous form is CO2 here. Okay. Now, if question says the residue is found to weigh this much, it means residue is this part because carbon dioxide will escape out.
Yes.
This will be the residue, and this is 18 gram. Say this is X gram carbon dioxide which escaped out because mass is asked. So assume that X grams. And the sodium bicarbonate is given 6.3 grams. Acetic acid is given 15.0 grams. So if everything is in mass, so it is law of conservation of mass. Means
Yes.
sum of the masses of reactants should be equal to sum of the masses of products. So you will say x plus 18.0 equals to 6.3 plus 15.0, that is 21.3. So x will be 21.3 minus 18.0, that is 3.3 grams. And this will be law of conservation of mass. Yes, Kavish Atman, correct. Law of conservation of mass and 3.3 grams. Now here it is easy question. Sometimes uh, there will be a twist, and that twist will be when we will cover the limiting reagent. So this is a straightforward question where we are not looking for that there is any chance that there will be some of the reactants which can be unreacted. Okay, so in few cases, although these amounts are given, but there is a chance that some amount of any of the reactants remains unreacted because that is in excess. That is something we will discuss in limiting reagent. Next question. 2 grams of a metal burnt in oxygen gave 3.2 grams of its oxide. You have a metal and you have metal oxide. Okay. So if you have 2.8 grams of metal, you get 3.2 grams of metal oxide. If you have 1.42 grams of same metal, you get 2.27 grams of metal oxide. Question is, which law is shown by this data? Okay. Now you
Sir,
might
it
think
is 2.0 gram.
0 gram, okay, so 2.0 gram. So 2.0 gram gives 3.2 grams of oxide, 1.42 gram gives 2.27 grams of oxide. And this question is slightly tricky because you might think that we are talking about metal and oxide. We can calculate the ratio of oxygen, keeping the metal constant. We might get it as law of multiple proportions. But here it is slightly different. Okay. Here, in all such questions, and you will get answer correct, whether it is law of conservation of mass, whether it is law of constant proportion or constant composition, same thing, or whether it is law of multiple proportion. Specifically, law of constant composition and law of multiple proportion. The
Sir,
concept,
it's law of constant composition, no, sir, in this case.
yes, yes. But the approach will be how you will identify. Approach is same for both. Okay, and listen it carefully. What is the approach? Approach will be that you will always consider metal or one part as 1 gram. Okay, so you will calculate if this is the relationship. What will be the relationship if it is 1 gram? How much it will be? Similarly, what will be the relationship if this is 1 gram, how much you will get here? I'm repeating it. The approach will be same, and you will get to know based on what you get on that basis whether it is law of constant composition or it is law of multiple proportion. So in this case, first calculate for first part. Okay, here from these values for 1 gram metal oxide will be 3.2 divided by 2.0. Unitary method means 1.6 grams. Second one will give you for 1 gram metal oxide will be 2.27 divided by 1.42. Here again you will get 1.59 something, which is approximately 1.6 grams. It means whatever oxide you have, if it is 1.6 grams total, 1 gram is metal. If it is 1.6 gram total, 1 gram is metal. It means whether you prepared it by burning in oxygen or you prepared it by heating in steam, there are two methods. So source is different. One source is by burning, the other source is heating in steam. So burning means burning with oxygen. Heating with the steam means reacting with H2. But the composition you got same. Metal versus metal oxide. If this one is 1 gram, this is 1.6 grams. It means the mass of metal and mass of oxygen is constant, irrespective of the source. Okay. It means here the metal is 1 gram, oxygen is 0.6 gram. In this case also, if metal is 1 gram, oxygen is 0.6 grams because total is 1.6 grams. Hence, it is law of constant composition. Composition is same. 1 gram metal is present in 1.6 grams of metal oxide, whether we obtained it by burning or whether we obtained it by heating in steam. So it will be
Sir,
law of constant
sir,
composition.
I had another doubt, sir. In such type of cases, sir, is it possible to even apply law of multiple proportions, sir? Because there is only one element in one of the given data, sir. So how can we use
Metal
multiple
oxides can be
proportion?
different. For example, Fe2O3 and Fe3O4.
Yes, sir.
So in
Sir,
that case,
but
you have to find it.
in this case, sir, but in this case, the metal is a single element only. So, sir, can we still apply law of multiple
Still, you
proportion
will
in
see
such
in
thing?
one of the questions we are going to do, you will see, okay?
Okay, sir.
We can. That's why I said approach is same. You will calculate for 1 gram. 1 gram, if
Okay, sir.
metal oxide is same, then it will be constant composition. If it is not same, then we will talk about the law of multiple proportions. Because that's why I have written MXOY, because it can be NO2, it can be N2O5. Both are nitrogen and oxygen, but proportion is different. So in that case, it would have been law of multiple proportion. And we will talk about that. Carbon and oxygen are known to form two compounds. The carbon content in one of these compounds is 42.9%, while in the other it is 27.3%. Show that the data are in agreement of law of multiple proportion. Similar question, okay? Similar question that you have carbon and oxygen only. So these are oxides of carbon. But in one case, carbon content 42.9, in other case, carbon content 27.3%. So write it like carbon, oxygen. So it is for carbon is 42.9%. So suppose we have 100 grams, so it will be 42.9. And here, oxygen will be 100 minus 42.9. In second one case, 27.3, it will be 100 minus 27.3, right? because percentage is given. So we can consider 100 grams, then it will be 42.9 grams and 27.3 grams carbon. Now it says show that the data is in agreement with the law of multiple proportion. I told you in previous question, approach will be same. So first calculate here, 100 minus 4357.1.
57.1.
100 minus 2868.7. Sorry,
Or 72 point.
72.7,
The 72.7.
right? Now these are the values. With this one, calculate in 1 gram. From first, in 1 gram, for 1 gram of carbon, oxygen content 57.1 upon 42.9 grams. From this one, for 1 gram of carbon, oxygen content 72.7 divided by 27.3. Approach is similar. Okay. Now simplify this one. 57.1 divided by 42.9 will give you 1.33. Okay. And 72.7 divided by 27.3 will give you 2.66. Now have the table. Carbon, oxygen. For 1 gram of carbon in each, in first case, oxygen is 1.33, in other case 2.66. And the ratio of these two is simple, whole ratio. And that's what the law of multiple proportion says, that if two elements can combine to form more than one compound, then keeping mass of one as constant. So here mass of carbon we have fixed as 1. The other two compounds will have a simple whole ratio by mass, and it is 1:2. The ratio here is 1:2, which is simple whole ratio. Is that clear? If you remember the multiple proportion law,
Yes, sir.
okay. In multiple proportion, we keep the mass of any one element constant, and then we calculate the ratio of the masses of other element. Ratio of the masses of other element 1.33 is to 2.66. 2.66 is just double of 1.33. So the ratio is simple whole ratio. Hence, law of multiple proportion is in agreement with this. Any confusion?
No, sir.
No, sir.
Next question, similar to previous one. And I would suggest that you do it, try to do it yourself first. Here, rather, it is easier because in previous case, we had to calculate the other compound by subtracting it from 100, because we considered it 100%, so 100 gram. Here, both values are given. Phosphorus, this much percent, chlorine, this much percent. So this value is already given. You don't need to subtract. Similarly, in second case, phosphorus, these many grams, chlorine will be these many grams. Apply it. Just have your notebook and pen, grab it if you don't already have. And the rule is simple. Fix phosphorus here. So calculate in both cases, if phosphorus is 1 gram, then how much chlorine will be there in both cases. And then calculate the ratio of chlorines. If that is simple whole ratio, you will say it follows law of multiple proportions. Try it yourself first. I am giving you 1 minute. You can just post the values you got for 1 gram of phosphorus. In first case, what is the value of chlorine you got? In second case, what is the value of chlorine you got?
And sir, do we also have to find the ratio like we did in the previous question?
Yes, yes. Pratham, your values are correct. And then you need to show that these are in simple whole ratio. Yes, Tanu, your value is correct for first one. Everyone, you need to utilize this time. Don't waste this time. Utilize it, and you will see that you will be able to solve these type of questions very easily in examination. Devyansh, yes, correct. Okay, now this much time should be sufficient for most of you. Okay, I'm getting quite a few answers. Let me get. Tanu, yes, correct. Devanshi, yes. Kartike, yes, good. Samad, yes, correct. Savya, yeah, that is correct, but you have approximated it. Arjun, yes. So the second part is absolutely correct. Arna, there seems to be some calculation mistake. Devanshi, no, 1:2 will not be there. Okay, Kartike, this one is correct. Pranav, no. Okay. Many correct answers, still many correct answers. Write it in same fashion. You have phosphorus and chlorine. In first case, yeah, or draw the table if you want to. That ensures that you don't make mistakes. You have phosphorus and chlorine. You need to calculate for 1 gram. Okay, for 1 gram in first case, for 1 gram in second case. In first case, it is given phosphorus is 22.54 gram if we consider assuming 100 gram of each sample. And chlorine will be 77.46 grams. Hence, if phosphorus is 1 gram, chlorine will be 77.46 divided by 22.54, and it will be 3.436 approximately gram. So for 1 gram, in first case, you got chlorine 3.436 grams. In second case, phosphorus is given 14.88 gram, chlorine is given 85.12. Percentages, these are percentages out of 100, so we have assumed 100 gram. Hence, for 1 gram, chlorine will be 85.12 divided by 14.88. When you solve this one, you will get 5.72 grams. What you have to prove? You have to prove that these two are in simple whole ratio. These two are in simple whole ratio. Now remember, some hint you need to get from. Okay? Phosphorus and chlorine combined like PCl3 and PCl5. This is something you should already know. It will help you to find the simplest ratio. So logically, it should be 3:5. Logically, it should be 3:5. How to find? Now, this one is something that how to find. So first, what you will do, you will get ratio as 1:something. So if you divide both by 3.436, this one also 3.436, then you will see this will be 1, this 2, this one will be 1.666. Now from here, again mathematics, and you have to know these type of tricks here. 0.6667 or 0.67 is nothing but 2 by 3. You know 0.67 is nothing but 2 by 3. 0.33 is 1 by 3. 0.666 is 2 by 3 approximately. It means this one you can write as 1 and 2 by 3. This is 1 plus 2 by 3, which is written as 1 and 2 by 3. 1 and 2 by 3 in mixed fraction and 1 plus 2 by 3. These are same thing. So it is 1 plus 2 by 3 actually. So you write it as 1 and 2 by 3. From here you can simplify it very easily because now it is 1 is to 5 by 3. Now it can be simplified very easily. Multiply both by 3. So just a bit of these techniques you need to learn, and you will be able to convert the decimals into simple whole ratio. So remember what
Sir,
I got?
can you please explain why did you divide 3.436 by both these numbers? So both these
Because
masses.
I wanted to simplify it. Otherwise, these are far away from simple whole ratio. 3.436, 5.72, these are not close to any integer, right? And we are trying to find out to convert these to simple whole numbers, that is integers. So what I did, I converted 1 to integer. When I divided this by same thing, I converted it by 1. But I just can't divide one number. I will have to divide both by same number so that the ratio does not change. This is something you know from your 6th, 7th, 8th grade, that if two values are there, ratio is there. For example, I am talking about 5 is to 10. I can divide both by 5 and the ratio will not change. I will divide it by 5, will divide it 5. 1 is to 2. So it is effectively 1 is to 2. 5 is to 10 is effectively 1 is to 2. How I got that? I divided both by 5. Okay. In this case, why I did that? Because in this case, I had 3.436 and 5.72 say 0 here. None is close to integers. And if I multiply 1 by something, even then I am not sure whether I'll get integer or not. So in those cases, I will convert 1, the smaller one, to integer. Is this clear? Up to here, is that
So,
clear?
sir, we have to bring any
Yes,
one of
sir.
the numbers to the ratio of 1, then the other one will be calculated,
Yes, yes.
be it in
That's what I'm
fraction
saying.
or whole number.
And the number which you will convert to integer will normally be the smaller one. The smaller one, I converted to 1. And here I got 1.67 approximately. And then I applied my knowledge that it is actually 1 plus 0.67, and 0.67 is nothing but 2 by 3. So I will convert the decimal to fractions, and by fractions it will be easier for me to get the whole number. So 1 plus 2 by 3 is nothing but 1 and 2 by 3, and 1 and 2 by 3 is actually 5 by 3. So the ratio is this one. Now I can, as I divided by same number, I can multiply by same number. So now I multiplied both sides by 3. Why I multiplied by 3? Because I want to get rid of this denominator. So 3 got
Sir,
cancelled.
so if it was even, sir, 1 is to 5 by 3, so, sir, 3 comes in the numerator also, no, sir? So
Yes,
from there we get 3 to 5.
yes, yes.
And sir, I had another doubt, sir. What I did was that this when I divided 3.436 by 5.72, sir, it came out to be 0.59. It was coming out till these two digits. So, sir, I converted it to 0.6. So I showed it in the form of 6 by 10. Is that okay, sir?
No, no. That's what I'm saying, that mostly you should convert the smaller one to 1, not this one.
Okay.
not this one. So convert this one to 1, and the other one you need to find out in fractions, in the form of fraction. Convert that to fraction. So these approach you need to remember, because otherwise in examination, if you don't know these tricks, in examination you won't be able to convert the decimals into fractions and then fractions to ratio. Approach is very simple, and in today's class till now I have told you two things which are important. The first thing, that you will always make one element as 1 gram, and you will calculate the mass of other element in grams with respect to 1 gram of the other one. That is one thing which I told you, you will remember. The other is how to convert the decimal ratio to simple whole ratio. This is the technique. Clear? And you need to do practice if you are still confused.
So just one thing, sir. You had sir, you had calculated that 1.67 number. So, sir, how did you get that, sir?
This much is you will do calculation. You will have to do calculation,
So,
right?
so from this part only you received that.
Yes. So you
Okay,
will
sir.
have to do this calculation.
Okay, sir.
Why I
Okay,
am telling you, because I remember that. Okay. Otherwise, it will require calculation. It will require your time. Okay? So when you divide, you will get 1.666 something. Then you will say it is 1.67.
okay, sir.
If any confusion is still there, let me know. The approach in all three questions we have done is similar in these ones. Okay. The first question was obviously different. Yeah, just the law of conservation of mass we applied. In this one, again, law of conservation of mass, but the approach was same. We calculated for 1 gram, and the other one was same thing. So that's why it is law of conservation of mass, not law of multiple proportion, because the ratio is not 1 is to 2, 2 is to 3. It is just 1 is to 1. It means it is same compound we are talking about. These are not two different compounds. It's the same compound we are talking about. And in other questions, two questions here, again, we calculated for 1 gram of one element. We calculated the respective mass of other element. Here also, for 1 gram of one element, in this case phosphorus, we calculated the respective mass of other element and then the ratio of that. Is the approach clear?
Yes.
If there is any
Yes.
confusion,
Yes, sir.
you need to ask, okay? Next, three oxides of lead on analysis were found to contain lead as under. In such questions, you don't need to bother about what the formula is, because you just need to show that they are in simple whole ratio. If you fix the mass of lead, these are all oxides, okay? Oxides of lead. So one is yellow oxide, the other is brown oxide, the other one is red oxide. It means in all you have lead and you have oxygen. Okay. So normally lead oxides are PbO, PbO2, and Pb3O4. In redox chapter, we will talk about that. This is actually combination of these two. Okay, not here.
Yes, sir. Just like we get Fe3O4.
Yes, correct. Okay. So these three oxides basically we are talking about, but we don't bother about these in such question. What we need to do, we need to fix, in all cases, we need to fix the mass of lead as 1 gram, and then we calculate the mass of oxygen. These three should be in simple whole ratio. Then it will be law of multiple proportion. By now it should be clear. It is similar to previous two questions. Okay, that's what we will do here. So we will have lead and oxygen. Lead is, sorry, oxide is 3.54. Lead is this much. 3.45 gram of yellow oxide contains 3.25 gram of lead. It means you don't just divide this by this, no, because this is lead oxide, not oxygen. So first you will calculate how much oxygen is there. So in this case, oxygen will be 3.45 minus 3.21, means lead oxide minus lead. Is that clear? This one is lead oxide. This one is just lead. So to calculate oxygen, you need to subtract the lead part from lead oxide. Remaining will be oxygen. Just for example, say lead oxide is 3.45 and lead is 3.21. So it means here this is Pb plus O, lead oxide. PbO is actually Pb plus O, 3.45, and this one is only lead. How will you get the oxygen? Oxygen you will get 3.45 minus 3.21. 0.24 gram will be oxygen there. So here oxygen is 0.24 grams. Here oxygen will be 1.195 minus 1.035,
0.16 grams.
0.16 grams. Here oxygen
So
will be
same in third,
1.77,
same.
0. Same it should not be. It is same. Yeah, that's right. Yes, it is same. Anyway, so we calculated that oxygen, in this case, lead is 3.21, oxygen is 0.24. In second case, lead is 1.035, oxygen is 0.16. In this case, lead is 1.61 and oxygen is 0.16. Any confusion till here, you need to ask. Remember to calculate the ratio of oxygen in all, we have to get oxygen first. So first task here was to get how much oxygen is there in each oxide. To get the oxygen, we have subtracted the mass of lead from whole compound. Now you need to calculate for 1 gram of lead how much oxygen will be there, or for 1 gram of oxygen how much lead will be there. Both cases will give you the same answer, but we will take lead as 1 gram. So now I am extending this table. Lead, oxygen. Now if it is 1 gram, this is 1 gram, this is 1 gram. Then oxygen will be 0.24 divided by 3.21. Who is not clear about it?
Sir, didn't you say that we should take the element with the lesser mass as 1 gram?
No, I didn't say that. I said while calculating, simplifying the ratio, you should consider the lower one, the smaller one.
So
be
to get it to
converted
1, yes, sir.
Here I said, here I didn't say. Yeah, that is something I talked about the ratios. So when you are converting 3.436 is to 5.720 in simpler form, there I said that you need to divide the smaller one by itself to get one. Okay. For that, I talked about simplification of ratio, not here while calculating for 1 gram. Okay. So here you can take any, answer will be same. Now tell me who is not clear about it. I am applying unitary method that if when lead is 3.21 gram, oxygen is 0.24 gram. Lead, oxygen. When 3.21 gram lead is there, oxygen is this much gram. Hence, for 1 gram, how much oxygen will be there? Is that clear for everyone or not?
Yes,
Yes,
sir.
sir.
Confusion you need to let
Yes,
me know,
sir.
okay? So for 1 gram of lead, I calculated how much oxygen will be there. Similarly, here it will be 0.16 divided by 1.035. Here it will be 0.16 divided by 1.61. And I need to calculate these values. Just give me a few seconds. I will be using calculator, but you must do all these calculations as practice. If you leave these as, you can do it in examination, there are high chances that you will make calculation mistakes. So do practice your calculations when you are doing the numericals. So it is 0.24 divided by 3.21. It gives you 0.075. It gives you 0.075. I'm writing it here, 0.075. Then 0.16 divided by 1.035, you get 0.15. Say we have three decimal places here. Then 0.16 divided by 1.61. I get 0.0999, so it is actually 0.10. Yep. Now again, slightly tricky. You need to simplify this one to say that these are in simple whole ratio. These are the ratios of oxygen. Oxygen is present in all three oxides. If we compare, this is the ratio of oxygen if lead is fixed. So what we have done, I am repeating, I have fixed the mass of one element, in all three cases 1 gram, and then I calculated corresponding to 1 gram how much oxygen is there, and I have got ratio of oxygen. If I can prove that this is simple ratio, then I will be able to prove this is law of multiple proportion. Now here you see something. If you multiply this by 2, you get 0.15. 75 into 2, just simplify. I'm
150.
writing it, okay? It is 0.075 is to 0.150 is to 0.100. First of all, remove decimal places. Multiply all by 100. Multiply it by 100, this by 100, this. So this will be 7.5. This will be 15. This will be 10. Instead of 100, multiply it by 1000. Then it will be rather easier. You will get 75, 150, 100. Now divide all by 25. All are divisible by 25.
Yes, sir.
Divide by 25. 3 is to 6 is to 4. Other methods are also applicable, but this is the easiest one here. Remove the decimals, divide by 25, simple whole ratio. And that's why you will say that as for fixed quantity of one element, that is lead here, the ratio of the masses of other elements is in simple whole numbers. It means it complies with law of multiple proportions. Anyone not clear about it? Which step is not clear? Let me know.
Sir, can you please explain it again? Once again?
Which step is not clear?
Sir, please come to the other screen. Sir. Sir, why did we remove the decimal? I'm not sure about this.
To simplify it to the simplest whole ratio. Otherwise, it is anyway, even here, if you divide these by 0.025, you will get the answer, but that will
So
become.
we have to divide all by the HCF to get the
Yes,
simple
correct.
whole ratio.
Correct.
Okay.
And that will be cumbersome. So it is always easier to convert these numbers into whole integers, complete integers, or at least fractions. Otherwise, it will be difficult to find the simple whole ratio. So in one case, I told you to convert it into fractions. That is easier way. Okay? Because if you get in fractions, for example, 1 is to 3 by 4, it is very easily you can convert it 4 is to 3 because you need to multiply both sides by 4. 4 is to 3. So either convert the ratios in fractions or convert in whole numbers, big whole numbers, and then simplify. This is the approach to simplify the ratios which are in decimals. So in decimals, the calculations are cumbersome. That's why I converted it to integers. Is that clear?
Yes.
Yes, sir.
Now, before I move to next question, a bit of about mass percent. Mass percent is something you already know how to calculate the percentages. It is simply the same thing we do. We will be using it in next question. So mass percent is nothing but if we are talking about in terms of atomic mass and molar mass, sorry, mass percent of an element. Say I'm talking about CO2. What is the mass percent of carbon in it? So mass percent, if I say 1 mole, carbon will be 12 gram, oxygen will be 16 to the 32 gram. So mass percent will be 12 gram divided by total 44 gram into 100. This is how you calculate the percentages. You have the value here, for example, profit, percentage profit. So here you will have profit. Here you will have total amount, initial amount, and then you will multiply it by 100. Here again, to calculate the percentage, whatever percentage you are calculating of mass of that one divided by total mass into 100. So the formula will be atomic mass of the element of which you want to calculate mass percent divided by molar mass into 100. For example, you need to calculate the mass percent of calcium. So if you see calcium, atomic mass is 40, carbon is 12, oxygen 16 threes are 48, total 100. It means in 1 mole, there will be 100 grams of calcium carbonate. But out of these 100 grams, how much calcium will be there? Only 40 grams. So mass percent of calcium will be 40 gram calcium divided by total 100 gram calcium carbonate into
So can we write this formula as molar mass upon molecular mass into 100
molar mass.
of the element?
Okay, you can write, right? Because anyway, we are not writing the unit here in this case. Yeah, so you can write molar mass of the element because that will be in grams. That makes sense. Molar mass will be grams per mole. So that makes sense.
Sir, so if we had to calculate for oxygen, then we had to multiply it by 3, or sir, how would it
No,
be?
no, no. In that case, you will consider 48 here. So
Yes, sir, that
mass
only I
of
was saying, sir.
oxygen will be
16 into 3.
48 divided by 100.
Yes, sir, I meant this one. Okay, sir.
So whatever mass is of that element, that will be in numerator, total will be in denominator, and you will convert that to percentage by multiplying it by 100. Okay. So you can very well write here molar mass because for elements, atomic mass is actually molar mass. Molar mass does not mean molecular mass. Okay. Because molar mass means one mass of 1 mole. Whether moles are in terms of atoms or these are in terms of molecules, that is different thing. Molar mass means mass of 1 mole. So you can very well write like this. Now come to the question. Question says two oxides of a metal contain 27.6% and 30% of oxygen respectively. If the formula of first compound is this much, means related to this one, in which the metal is oxygen is 27.6%. In second one, It is 30% of oxygen. You need to find formula of that one. The question simply says you have metal oxides M3O4. In this one, oxygen is 27.6%. There is another metal oxide, yeah, of same metal, and their oxygen is 30%. You need to find the formula of that metal oxide.
Sir, so we find the formula by equating the like the mass of the other, so this M thing, we find the name of the element. So for M.
No, basically, first we will calculate the atomic mass of this one. We don't know. So with this one, we will get the atomic mass of M. And from that, we will use it to calculate these values. How we do it, it is slightly tricky, I'm telling you. So you will have to understand what I'm doing, and I'll have to explain it twice. So first, understand the question. Sometimes students don't understand the question, and that's why they struggle. That's why I'm first making you understand the question. What question says? Question says you have two metal oxides, same metal. Okay, metal is same, but there are two oxides. In one oxide, the percentage of oxygen is 27.6. In another one, it is 30%. Percentage of oxygen is slightly greater. In which the percentage of oxygen is 27.6. For that, the formula is given. M3O4 means metals are 3 moles, then oxygens are 4 moles. Oxygen atom. It is given. You will apply the mass percent formula here first to get the actual atomic mass of this one. Oxygen, you already know, 16 atomic mass. This one you can find out with the data given.
Sir, to in order to find M, sir, we have to get the molecular mass. Sir, so is that obtained from oxygen? Sir, when we make an equation.
We will make equation of the formula of this one.
Yes, sir. Sir, I wrote it for oxygen as 16 into 4 by 100 of X equal to 27.6 to get the molecular mass so that I can use it for M.
You are close. You are close. Okay.
Okay. Sir.
Now, how to get the answer? Answer will be, this is percentage of oxygen, and by using the previous formula, you can calculate percentage of oxygen here. In this case, mass percent of oxygen is given 27.6%. And mass percent of oxygen will be mass of oxygen. I'm explaining it on next. Mass percent of oxygen is given 27.6%. And mass percent of oxygen will be, as per formula, mass of oxygen or atomic mass of oxygen divided by molar mass of compound into 100 equals to 27.6. Is this clear up to here or not? I have applied
Yes.
the formula.
Yes, sir.
This mass percent is given for oxygen. Now, atomic mass of oxygen, correct, but here we will actually call mass of oxygen. Why? Because here there is not just one oxygen atom. How many oxygen atoms are there?
Sir, 4.
4. How many metal are there? 3. So we will assume something here. We will say, assuming atomic mass of metal is X. Then mass of oxygen will be mass of 4 oxygen. So it will be 4 into 16 divided by, I'm just writing the formula, it is given as M3O4. So O4 means 16 into 4, 4 into 16. Total will be, if atomic mass of M is X, total will be 3X plus 16 into 4. Is this clear or not? Molar
Yes.
mass.
Yes, sir.
Molar mass of M3O4 will be 3x plus 4 into 16. That is 3x plus 64. So
So
write
can
it.
we use the concept of 100 gram here
Not
to
here.
get the
Not
mass?
here, because here you will calculate actual, then you will multiply by 100 to get the percentage.
Okay, sir.
So this one is molar mass. This is not actually the mass. So you are calculating in 1 mole. In simple terms, if you want to understand it, we are considering that we have 1 mole of M3O4. This is what we are considering. If we have 1 mole of M3O4, how many moles of oxygen atom will be there? 4 moles of oxygen atom. Because there are 4 oxygen atoms, so 4 times oxygen atoms. And what will be the molar mass of this one? 3x plus 4 into 16. That is 3x plus 64. Because we have considered as 1 mole, that's why.
Yes, sir.
Yes. So assumption is there that we are assuming we have 1 mole. For 2 mole, again, it will be same thing because ratios don't change. For 2 moles, again, the fractions will remain same. Ratios will remain same. Only it will be 2 into here and 2 into here. That will be the difference, and 2 and 2 will get cancelled. So we will always consider 1 mole into 100 equals to 27.6. It means 64 into 100, 6400 equals to 27.6 multiplied by 3x plus 64. Cross multiplication means 6400 equals to 27 threes are 82.8. Okay, plus 27.6 multiplied by 64. 46671. So 1766.4 means 82.8x will be 6400 minus 1766.4. Okay. Right. Then x will be 4633.6 divided by 82.8. This is something you will have to calculate. Let me just calculate. So it will give you 55.96, that is approximately 56. So from here you got the atomic mass of metal, and 56 is of iron. Okay, 56, if you know, is atomic mass for iron. 26 is atomic number, 56 is atomic mass for iron. Now, how to use this value? The other one is oxygen 16U, and metal is 56U, oxygen is 16U. How to use it to find the formula of the other one?
So,
Now this, yes,
like we can't do it by unitary method. So like 27.6 gram will react like
no, no, no. That is not applicable here because here we are talking about percentages, different percentages in different. We are not talking about, the law of constant composition or law of multiple proportion. Okay. So if that is to prove, then in that case, those formulas will be given, and then you can do that. Here formula is asked, and there can be any ratio. Ratio can be 1:2, 2:3, 3:4, 4:5. You don't know that ratio. So that's why you need to first calculate that ratio. Are you getting me what I'm saying?
Yes.
If two compounds are given, for example, Fe2O3 and FeO, these two compounds are given, yes, you can show that this will be Fe2O2 and this ratio will be 3:2. Very simple. But it can be Fe3O4 also. You don't know what is the formula of the other compound. That is asked actually. So because you don't know, you can't fix the amount of one and tell the other one. Is that clear?
Yes.
So now there is easier way to do it. The easier way is that you know now metal and oxygen, you know atomic masses 56 and 16. And one very important point which you need to remember, any compound, for example, I am talking about Fe2O, Fe3O, because I know it is 56, it should be iron. So M3O4 is Fe3O4. This is actually the ratio of their moles. It means there are 3 moles of Fe atoms and 4 moles of oxygen atoms. Why? Because actually, if you consider just molecule, there are 3 atoms of iron, 4 atoms of oxygen, and if you multiply both by Na, these will become moles. So it means these values are nothing but the moles, molar ratio. This concept we will use now. And we will use the concept of conversion. You know from mass how we can calculate moles. Who will tell me? If we know the mass, how we can calculate the moles?
So,
Yes,
sir, if for example, we know that one mole is equal to 6.022 into 10 to the power 23 molecules, and
no,
if the,
we won't go
Sir,
into
given
numbers.
mass by molar mass.
Exactly, so simple. If you know the mass, you remember that diagram, I hope.
yes, sir, Samali.
And this is actually you need to use again and again. So to convert mass to mole, it will be given mass upon molar mass. And that is the concept you need to apply here. Because what we need moles. The moment we get moles, their ratio will tell us the formula. Because I am telling you that Fe2O3 or Fe3O4 is nothing but there are 3 moles of iron and 4 moles of oxygen. So suppose the other formula is FeXOY. So we need to get the moles of iron and the moles of oxygen. What will be moles of iron? It will be its mass given by divided by its atomic mass. And what will be Y? Y will be oxygen mass divided by 16. Is that clear or not? And our aim is to get the value of X and Y. The moment we get X and Y, we will get the formula. Is that clear or not?
Yes,
If anyone is not clear about it, tell me. If it is H2O, it means it is, if I consider it as AXBY, okay, then X is 2, Y is 1. Okay, it means I have 2 moles of hydrogen atoms and 1 mole of oxygen. So whatever we see as suffix is nothing but how many moles are there of that particular atom. We will apply the same logic here for the second one. And for the second one, what is the percentage of oxygen? 30%. It means mass, first I'm writing mass. Okay? Now I'm talking about the compound which we need to find out. For that compound, it is given, if we consider now 100 gram, there will be 30 gram oxygen, 100 minus 30, 70 gram metal. This is something we know. And we have also calculated atomic mass of metal. And for oxygen, we already know atomic mass. From this data, we can calculate how many moles are there, given mass upon molar mass, given mass upon molar mass. Is that clear or not?
Yes,
How
sir.
I got the moles?
Yes,
Given
sir.
mass divided by molar mass. It means this is the value of X, this is the value of Y. Whatever you get the simplest ratio of 70 by 56 and 30 by 16. I'm just writing again. It is mx oy 70 gram, 30 gram, 56u, 16u moles. That is here x will be 70 by 56, y moles will be 30 by 16. So when I simplify these, I'm just using calculator. You should use your copy pen. 70 divided by 56 will give you 1.25, and 30 divided by 1.6, sorry, 16. 30 divided by 16 will give you 1.875. Okay. Now, how to calculate the simplest ratio? Again, something which is you need to remember most of the times. With practice, obviously, you will remember quite a few things. Okay. That's how to simplify these things. So first, you can, the simplest way can be that divide both by 1.25, but this is lengthier way, remember, because when you divide uh, in decimals, it requires longer time. Okay. So let me divide 1.875
Yes, sir.
by 1.2.
So we have to get rid of the decimals now.
Yes, it is. Yes. So 1 is to 1.5. Now, when you simplify this one, it means it is 2 is to 3. It means it is M2O3. The compound is M2O3. And if you remember, I said metal is iron. Iron does exist, iron oxide does exist as Fe2O3, as Fe3O4. And Fe3O4, again, we will talk about in redox chapter, is a combination of FeO and Fe2O3. When you combine these two, you get Fe3O4. So there is no such compound Fe3O4. It is actually a mixture of FeO and Fe2O3. So
Sir,
this
can you
was
please
given.
explain one step, sir?
Which step?
Sir, how did you relate the data, sir, we received from the first part to the second one? Sir, just
Okay.
that
Okay.
step.
What I am doing, I am explaining the whole question again.
Okay, sir.
And these type of questions, as I said in the beginning, I'll have to explain twice. You have one metal oxide, M3O4, and the other one is MXOY. You don't. In first case, you know oxygen is 27.6%. This one will be some percent. You consider it as 100. Suppose if you consider, then then you can get percentage 27. Then this one will be some percent. But if I talk about the molar mass, and I consider the atomic mass of this one as X, the molar mass of this one will be 3X plus 4 into 16. That is 3X plus 16. Is that clear?
Yes, sir.
Oxygen 27.6%, 30%. Now I will make use of this data given that the oxygen percentage is 27.6. So I know that this whole is molar mass of whole one, out of which 64 is oxygen. So percentage oxygen will be oxygen divided by total into 100. This one will be the percentage oxygen. Is that clear?
Yes, sir.
And this is given as 27.6. From here, I got value of X as 56 U. It means here also, I should not be using X because here I am using X. Let it be A and B. So atomic mass of metal I got as 56 U. Same will be applicable here. Here also, atomic mass now. Here 56 and of oxygen 16. Is that clear?
Yes,
I
sir.
calculated the atomic mass from the given data. Now I am using that atomic mass in calculation of the compound, second compound. There I have been given the mass of oxygen. Now here I will use it as percentage. So I will say, suppose I have 100 gram, then metal will be 70 grams and oxygen will be 30 grams. Oxygen is given 30%, 30 gram. Metal will be 70 grams. From this data, I can calculate the moles. Moles here will be given mass
Yes,
upon
sir. This
atomic
step.
mass.
Yes, sir. This
And
step you just explained.
yes, right.
Okay, sir.
And
Okay,
from
okay,
here
sir.
you will get the ratio as 2:3. That is M2O. So here I have just compressed it. You will do all the steps. You will write everything. Is that clear, everyone? Or if still there is any problem, any step is not clear, I'll elaborate that step. And make sure that you are able to solve these questions. All of these questions most probably are in the assignment. If you
So
will
it's
be- Yes.
so it's clear.
Now this part is specifically for those who are planning to appear in JEE and NEET. In this chapter, basically this particular law, then equivalent weight related numericals and normality. These are the topics which are not in NCERT, but these are in both NEET and JEE. JEE main. Equivalent weight and normality are not in JEE advanced, only in JEE main. But still there is no guarantee that these cannot appear in advanced. But if we consider last 6-7 years, they have followed the syllabus. So the questions related to normality, equivalent weight have not appeared in advanced, but in main. And this is typically slightly tricky. So if you are trying to appear in or planning to appear in JEE NEET, you need to understand this one. If two different elements combine separately with the same weight of a third element, the ratio of the masses in which they do so are either the same or simple multiple of mass ratio in which they combine. Again, similar to the law of multiple proportion. Because if you just read the definition, it may not be clear. But still, I would suggest that read the definition again so that when I explain, you are able to understand. Go through the definition twice before I start explaining. Now, if you understand, okay, what it means, okay, here instead of the ratio of masses, basically we are comparing the ratios. So if you read it again, it says simple multiple of the mass ratio. So it is multiple of the ratio, not multiple of the masses. That is slightly different. So either the ratio will be same or ratio will be multiple of ratio. Understand it what I mean? Means either say the ratio is 1:1. In one compound, the ratio is 1:1. Say. Then in another one, the ratio will be maybe 2:1. Now, if you calculate the ratio of these two, this you can write 1/1, this you can write 2/1. That is, it is 1:2. So the ratio of ratios will be simple whole ratio. How? I explain. Hydrogen combines with sulfur and oxygen to form two compounds. What is the difference in law of reciprocal proportions from law of multiple proportion? In law of multiple proportion, there are only two elements which are combining in different proportions. Here, fixed mass of one is combining with two different elements. That is the first difference you need to understand. Okay. So this says that in H2S, two parts, we have fixed hydrogen, two parts in both. Two parts, two parts. In H2S, two parts combined with 32 parts. Here we are talking about mass. Okay, parts means in terms of mass. And in H2O, two parts combined with 16 parts of. Okay, so we will calculate this ratio first. So according to law of reciprocal proportion, sulfur should combine with oxygen in ratio either same one, 32:16 means 2:1, or a simple multiple of it, or a simple multiple of it. So if you see sulfur two parts, oxygen one part, it will give you S2O. It will not give you the compound which you already know. That's why this rule is slightly different. That's why this part, or a simple multiple. How? First, I'll show it for SO2, then for SO3, because you know that sulfur and oxygen combine to form SO2 and SO3. How this rule is applied there, try to understand. In SO2, sulfur and oxygen combine in the ratio 32:32, because sulfur atomic mass is 32, oxygen 2 into 16, again 32. So the ratio here is 1:1. Now what you will do, you will calculate the ratio of this two. So the ratio of 2:1 to 1:1 will be 2:1, which is simple whole ratio. So what we are doing actually, we are finding the ratio of the ratios. That is the different point here which you need to remember. Now I'm going through the definition again so that you can understand. If two different elements combine separately with same weight of third element, these two different elements are oxygen and sulfur, which are combining same weight of third element, means H2, H2. Different elements combine with same mass of other element. Okay, then the ratio of masses in which they combine. Ratio of masses in which they combine. 16 grams of 2. That is 1:2. Are either the same or a simple multiple of mass ratio. Means either it is 1:2 or it is simple multiple of 1:2 of this ratio in which they combine. So that's what we have seen in SO2. It is 32:32. That is 1:1. And 1:1, if I compare with this one, 1/2:1/1, we have simply 1:2.
Sir, why are we comparing this with SO2?
Because that's the rule. This rule says that these oxygen and sulfur will combine in a ratio.
Okay, sir. So we have to prepare separately the formula of the two other elements that are given.
Yes. So I'll
And then
show it.
compare
I'll
it with the
explain it
initial.
very diagrammatically. Yes.
Okay,
you're
sir.
right.
Okay, sir.
So now first understand it with SO3 also, and then I'll make you understand with diagram. This is the diagram. If sulfur and oxygen are two different elements combined with hydrogen, same mass of hydrogen, then sulfur and oxygen will also combine together. And they will combine in a ratio which will be the multiple of the ratio of sulfur and oxygen here. So here sulfur and oxygen are combining in 2:1 ratio. Here as in SO2 it is 1:1 ratio, but 1:1 will be a multiple of this one. Either it will be same 2:1 or it will be a multiple of this one. Okay. So why it is a multiple of this one? Because if you consider right in fraction form, this is actually 2/1 and this one is 1/1. And
Sir,
if you
can the
see
multiple be in form of fraction or it has to be in form of whole number or something
multiple
like
will
that?
always be in simple whole ratio.
Okay, sir.
So if you do 2 divided by 1:1 divided by 1, it is actually 2:1, which is simple whole ratio. So ratio of ratio is simple whole ratio. So I'm writing it so that you remember. Here I am talking about ratio of ratios. Although it is not written in this form in book, is simple whole ratio. Which two ratios I am comparing? I am comparing first the ratio of sulfur and oxygen here. So this is the first ratio. And I am comparing with the ratio of sulfur and oxygen here when they combine themselves. So there will be again some ratio of sulfur and oxygen when they will combine themselves. So the ratio of this ratio to this ratio will be a simple ratio. That's what I am saying. Is that clear? And that's how you will be able to answer these questions in competitive examination. And questions will be slightly tricky, not just straightforward. Understand it with SO3. The same thing. In SO3, it is 32:3 into 16, 48. That is 2:3. And when sulfur and oxygen were in H2S and H2O, the ratio was 2:1. The ratio of sulfur is to oxygen was 2:1 when they combined with hydrogen. Okay? But when they combined themselves, so here it was 2:1. In when they were in H2S and H2O, the ratio of sulfur versus oxygen was 2:1. But when they combine themselves, the ratio is 2:3. Now see, that 2:3 is a multiple of 2:1 or not.
Yes, sir, into 1/3 gives us this number.
Okay, so 2:3 is to 2:1. It will be 1/3:1 or 1:3. Okay, whichever
Say
way you
32.
write, whether you write this one first or that one first, it will be simple whole ratio. So the first one, which you calculated 2:1, and the second one 2:3 when they are in combined form, when they combine themselves. So first one you are keeping when they were in H2S and H2O, and this one is when they combine themselves. So it is 2/1 is to 2/3. Okay, that is 1 is to 1/3 or 3 is to 1. Any confusion here? Basically, this simplification is your mathematics. I hope you are at least that much good in mathematics that you can simplify the ratios. If not, then practice. Any confusion here?
So what is this 32:48 ratio?
That is the ratio of their masses.
Okay, sir.
So we will have to learn the masses also, atomic masses.
Normally, normal ones you need to remember. And up to
Sir,
30,
till calcium.
up to zinc,
Okay,
I
sir.
would suggest you remember. But, the moment we complete third chapter, classification of elements, you will remember many, many atomic masses and atomic numbers because we will cover periodic table there. Normal ones, sulfur, oxygen, calcium, sodium, potassium, hydrogen, fluorine, oxygen, nitrogen.
So
At least
these were included
five.
it in the syllabus of 10th itself, sir, till 20,
Right.
till calcium.
So till there, at least you should remember. So, and you can notice that I'm always considering one mole. When I say 32 gram and 48 gram, actually I'm considering one mole. In one mole, there will be 32 grams of sulfur and 3 into 16, that is 48 grams of oxygen. Any confusion? Any other confusion? Let me know.
No, sir.
And this is specifically for those who are planning for JEE and NEET, or maybe your teachers. Sometimes school teachers cover these laws. Even if these are not in NCERT, CBSE, few school teachers cover this one. So if your teacher has done this or will be doing this, you need to do this anyway. Now, next question. And if you can understand this question, it means you understood the law of reciprocal proportions. Hydrogen sulfide H2S contains 94.11% sulfur. Water H2O contains 11.11% hydrogen. And sulfur dioxide contains 50% oxygen. Show that the results are in agreement with law of reciprocal proportion. Now, one thing I need to ask, and who will answer? When I started the class today, I said the approach for the law of constant composition and law of multiple proportion will be same. What was that approach? You need to apply the same approach here also.
Sir, the 1 gram concept, no, sir? In
Right.
1 gram of
But
something.
to calculate the ratio of other one, you need to fix one. You need to fix any one so that you can calculate the ratio of the other one. So somewhat that we will apply here. So for H2O, it is given the mass of hydrogen is this percent. Okay. So if we consider we have 100 gram of it, because percentages are given, so that's why 11.11 gram will be hydrogen and oxygen will be 100 minus 11.11, that is 88.89. So we got mass of hydrogen, mass of oxygen. In sulfur dioxide, again it is given that mass of sulfur is 50 gram. in sulfur dioxide, okay, there is 50 gram sulfur, 50 gram oxygen. Both will be same actually. I have written it, I think, opposite. Here I should write oxygen, and here I should write sulfur. Because oxygen is given 50%, although answer will not change. Oxygen is given, sulfur you will calculate by subtracting from 100. So in both H2O and SO2, you got the values: hydrogen, oxygen, sulfur, oxygen. Now let us fix the mass of oxygen as 1 gram. What we are doing here, we are fixing the mass of oxygen as 1 gram. And corresponding to 1 gram, we can calculate the masses of hydrogen and sulfur. Same method as we did in previous questions. Yeah. So for that, in H2O, 88.89 gram oxygen combines with 11.11 gram hydrogen, it is given. 88.89 gram oxygen combines with 11.11 gram hydrogen. Hence, 1 gram will combine with how much? So 1 gram of oxygen will combine with 11.11 divided by 88.89 grams of hydrogen. That is 0.12 gram, 125 gram of hydrogen. 1 gram of oxygen in water combines with 0.125 gram of hydrogen. Similarly, in SO2, it is given, we have calculated that 50 gram of oxygen combines with 50 grams of sulfur. 50 grams of oxygen combines with 50 gram of sulfur. Hence, 1 gram will combine with 1 gram. 1 gram will combine with 50 by 50, that is 1 gram of sulfur. So for fixed mass of oxygen, 1 gram, 1 gram, we have hydrogen as 0.125 gram and 1 gram. It means we need to calculate the ratio of these two. So the ratio of masses of hydrogen and sulfur, which combine with fixed mass of oxygen 1 gram, is 0.125 is to 1.
1:8, yes.
1:8. Okay. Now what we have to prove, that this ratio and the ratio of sulfur and oxygen when they combine themselves, okay, not sulfur and oxygen, sulfur and hydrogen, when they combine themselves, will be a multiple of this one. I am repeating. Law of reciprocal proportions says that the ratio of the elements which combined with fixed mass of other elements, so ratio of hydrogen and sulfur, okay, will be a multiple of the ratios when they combine themselves, that is H2S. When this hydrogen and sulfur will combine themselves, then there will be some ratio. These two ratios will be simple whole ratios. Calculate that. In hydrogen sulfide, what is the ratio? In hydrogen sulfide, mass of sulfur is 94.11. It is given. We can get the mass of hydrogen also, 100 minus this much. So mass of sulfur, mass of hydrogen, you can calculate the simple ratio, which is 1:16. Ratio of hydrogen to sulfur here is 1:16. However, ratio of hydrogen to sulfur, in this case, when they were combined with oxygen, the ratio was 1:8. Now, if we find the ratio of these two, 1:8 and 1:16, this is simple whole ratio 2:1. Hence, law of reciprocal proportions proved. Just let me know whether every step is clear or not.
Sir, can you explain, sir, in short, sir, that which things did you compare here?
Right. In short, I compared these things. In short, what I did. In short, first I compared these two. In these two, I fixed the mass of oxygen, 1 gram, 1 gram. And I calculated the ratio of hydrogen and sulfur, which came out to be 1:8 in this case. Is that clear? I did that.
Yes, sir.
Okay, I fixed oxygen and calculated hydrogen and sulfur. Then I calculated the ratio of hydrogen and sulfur here based on the masses given. Okay, and I got the ratio as 1:16. Then I calculated the ratio of these ratios, means ratio of this to this. That is 1/8 is to 1/16. These two ratios have simple whole ratio 2:1. It means law of reciprocal proportion proved.
So
Yes.
can't we compare the ratio of sulfur and oxygen first with H2S and H2O?
Yes, you can. Any combination is possible and
Okay.
will give you the same result. Basically, will prove the law of reciprocal.
Yes, sir. Sir, if we did with H2S and H2O, then, sir, what we would have done, sir, first we would have found the ratio of S and H2, then the O and H2,
No,
then we
not
would have
SNH2.
compared.
The S and O2.
SNO only. Because here
Okay, sir.
you have hydrogen common. So whichever is common, you will fix that one.
Okay,
if
sir.
you
So we
compare these
found
two,
the
you will
mass.
fix hydrogen. You will fix 1 gram of
Okay,
hydrogen.
sir.
And you will calculate masses of sulfur and oxygen, and you will find the ratio of sulfur and oxygen from here. And then you will find the ratio of sulfur and oxygen from sulfur dioxide. And
So
then you
in
will
both
compare
cases, the
these two.
masses are involved, sir.
Yes, masses are involved.
Okay, okay, sir. Sir,
Another-
so in such a method, do we need to involve 1 gram? Or
In
it's
every step you need to involve, in every such questions, you will fix the amount of any one, and that preferable amount is 1 gram.
okay, sir.
So I'm just explaining, suppose you first take these two. So what is common here? Sulfur. So you will fix sulfur as 1 gram. And corresponding to 1 gram of sulfur, you will find the masses of oxygen and hydrogen. Say hydrogen X, oxygen Y. So here the ratio will be X is to Y. Hydrogen is to oxygen ratio will be X is to Y. Sulfur is constant because sulfur is common. So first rule, you will make that element fixed as 1 gram, which is common. You can take any two. So you get the ratio of hydrogen and oxygen. Then you will calculate ratio of hydrogen and oxygen here, given on whatever masses are given. Okay, based on that, you will calculate the ratio here. Say it is ratio as W is to or A is to P. So then you will show that the ratio of these ratios will be simple whole ratio. These can be same also. If these are same, then it will be 1:1, obviously. Otherwise, simple whole ratio 2:1 or 1:2, 2:3. Like, is that clear now?
Sir, so from the percentage, we get the masses by using the ratio. Sir, so we first calculate the ratio of any two compounds, then compare it to the third compound.
Yes, but we didn't get the masses from the ratio. Rather, we got the masses from percentages.
Yes, sir.
assume
We
that
used
it is
the
100%.
percentages and made a ratio to get the
Yes.
masses
Yes.
for 1 gram. Okay, sir.
If anyone is not clear about it, if you are not willing to appear in JEE NEET, absolutely fine, you can skip it. But if you are, you need to be clear about it. And it is not that you can do a crash course simply afterwards and 2-3 months and it will, it will be sufficient. No, never. Those students who are just, preparing right from the beginning, they will be successful. Okay. If you are doing that, you will be successful. Those won't be successful who just wake up at the end of the 12th. No. Anyone, if it's not clear, let me know. Okay, so I assume that you are clear about it. I am just explaining it just once so that you can understand. What is the approach? The approach will be simple. Say it is A, B. I'm not writing the ratios, okay? And B, B, and A, B. So in first two, you will see one will be common. So B is common. And the other one will form the other compound, remaining ones. Always the law of reciprocal proportion will look like this. There will be two compounds in which one element will be common. And then the remaining elements will form another compound. Okay. So your job is to first find the ratio of A's to D from the given compounds, and then find the ratio of A and D from the third compound, and then prove that these two ratios are in simple whole ratios. When you divide these two ratios, you will get simple whole ratio. Is this diagram clear? Is the approach clear?
Yes, sir.
If you can understand the diagram, this approach, you will be able to solve the questions.